This is a video for AQA Further Pure Mathematics. Hyperbolic function section 2.3, which looks at integration using inverse hyperbolic functions. Well, the results that we met in a previous video, i.e. the derivative of sine inverse x being 1 over root 1 plus x squared, and the derivative of cos inverse of x being 1 over root x squared minus 1, can be then turned round to give us expressions for integrals. Because the integration is the reverse of differentiation, then clearly we have these two results. The integral of 1 over root 1 plus x squared is sine inverse of x plus a constant, and the integral of 1 over square root of x squared minus 1 is cos inverse of x plus a constant. We can generalize those a little bit further and show that we get the integral of 1 over root a squared plus x squared is sine inverse of x over a, and for 1 over root x squared minus a squared it's cos inverse of x over a. Notice that these are similar to formulae that would have meant for integrals which involve sine inverse and cos inverse, and you should look carefully at the differences between those. So now I just want to look at a couple of examples of how these are used to do some actual integrations. So for example, if we've got the integral of 1 over root x squared minus 25, well, this is straightforward because you can recognize here that we have the standard form where a is equal to 5 for cos inverse. So it's just a matter of comparing with this formula here to show that this must be equal to cos inverse of x over 5 plus a constant. For the second example, we've got the 1 over the square root of something squared plus, instead of just x squared, 9x squared. So we can see that it's similar to this formula here, which is sine inverse of x over a, but we must get the coefficient to be equal to 1 before we can proceed. So the way to go about this is to first of all factor out of that a value of 3 from the square root, 9 from the square root, which will become 3 when we take the square root. So we take out 1 over 3, and that will then be the integral of 1 over, and then we've got the square root of, and here it would be 16 over 9 plus x squared. So just check when you take that 3 back into that square root, it becomes 9, so 16 over 9 multiplied by 9 is 16, and then x squared multiplied by 9 is 9x squared. So we've taken out that factor from the x squared to make this equal to 1x squared. Now we have something which is exactly the same as our formula, standard formula, where we can see that a is equal to the square root of 16 over 9. In other words, it's the square root of 4 over 3. And therefore, we can now apply the standard result to give our answer, which is 1/3. Sine inverse, I'm going to write it as x divided by 4 over 3 plus a constant. And of course you could probably do that directly to give the answer 1/3 sine inverse 3x over 4 plus c. So the formulae can be used for expressions where it's not just 1x squared by first of all factoring out to make sure that we've got an expression which has got just 1x squared in it. That concludes this video, and in the next one we'll be looking at integration using hyperbolic substitutions.